24 hours. Is that right? Did I do that right? Let me just make sure. So 185 times 1800 divide by 20. Dang it. Divide by 24. Bingo. So 13,875 gallons would be your answer for number 3. Okay, let's take a look at 5 and 6 here. Sketch an example of a graph that is a function, and then one that's not a function. Well, remember, something that is a function means there is only one unique y for every x. So what that means is that a function is a relation where for every single x value there's only one unique y value. So you can't have two y values for only one x value, or else then that would be a vertical line. And so you'll remember that any function that we draw must pass the vertical line test. So something that is a function, could be like a parabola, because no matter where we draw a vertical line, it only intersects at one point. Something that's not a function is something where there could be several y values given one x value. So, something like that would not be a function because it does not pass the vertical line test. Remember us writing this, it fails the vertical line test. Let's take a look at 6. Madison purchased 5 more pounds of pecans. Okay, so I read this and I think plus immediately. So 5 more pounds of pecans than she did almonds. So she bought A almonds, but the number of pecans she bought 5 more pounds of pecans than almonds. So assuming she bought A almonds, if we add 5 pounds to that, that's how many pecans she bought. So let's see if this makes sense. Number of almonds she bought, number of pounds of almonds, plus 5 pounds equals the number of pecans she bought. Does that square up with what we read here? She purchased 5 more pounds of pecans than she did of almonds. So she has more pecans than she does almonds, which is what we have represented here in that equation. Pecans cost $4.25 per pound. Almonds cost $5.50 per pound. If X represents the number of pounds of almonds she bought, so X needs to represent the number of pounds of almonds she bought. Write an expression she can use to represent the total cost of the nuts she purchased. So the total cost of nuts she purchased is going to equal, so total cost is going to equal $5.50 per pounds of almonds plus $4.25 per pound, $4.25 per pound of pecans. But we know that our pecans, the number of pecans she bought was 5 more pounds than the almonds. So we can rewrite this. And I forgot, but X is representing almonds here. So $5.50, but I'm going to stick with A. $5.50 A plus $4.25, and what do we say P is equal to? X plus 5, or almonds, the number of almonds she bought, plus 5 pounds. So A plus 5 would be an equivalent expression. So there's our total cost right there. $5.50 for every pound of almonds, plus $4.25 for every pecan, which is the number of almonds she bought, plus 5. Okay, moving along to number 7. Okay, 7 is I'll show you a calculator shortcut that we can do for 7. Let's see here. Hey, where did I put? Okay, so let's fire up the calculator here, and I'll just show you the calculator shortcut to, quote, check your answer. Let's see here. Let's make that a little bigger. And, okay, good. There's our calculator. So what we can do is, let's come back to our problem, is we want to figure out what is the slope of the linear function shown in the table. So that's cool. They told us it's a linear function. So let's go to Stat, Edit, and let's put in our x values there. So we have -4, 0, 2, 6, and 12. Let's come over here and put in the y values, 11, 5, 2, -4, and -13. Okay, so we can run a simple regression on here and go Stat, Calc, go down to Linear Regression, hit Enter, Enter, and it runs a linear regression on that data. So we see y equals mx plus b. The calculator calls it a, but it's still the same thing. This is still a slope. So our slope is -1.5. So -1/2, which is the same thing as -3/2. So let's see if we get that when we calculate it by hand. So to get here, our change is a +4. To get here, our change is a positive, it's a -6. So this would be our change in y. This would be our change in x. So slope equals change in y over change in x, which we found to equal -6/4, which reduces to -3/2, which is the same thing as -1/2. Alright, let's take a look at 8. Name the correlation shown by each scatter plot. This really has no correlation. This has a general upward trend, a positive correlation. This has a downward trend, so this would be a negative correlation. And don't forget the old axiom, correlation does not imply causality. Let's see here. Well, you don't have to know that. That's just a very important logical rule for you to learn and memorize. Okay, anyway, let's take a look. Let's go down to number 9. Okay, 9 and 10. We're talking about more dependency here. Pen, activate. Alright, let's see here. Sketch a graph for each statement below. The hotter it gets, the more ice cream sold at lunch. And y'all always come into class with ice cream, and I'm always asking you, where's my ice cream? I never see any of that ice cream. So maybe this graph will teach you the value of bringing your instructor ice cream during the school year. So we notice the cause and effect here. The hotter it gets, cause, so this is the obvious cause, the more ice cream sold. So we always put the independent, the causation, the causal variable on the bottom axis. So we'll put, we can put temperature outside. I'll just write temperature. And we can say ice cream sold at lunch. I don't know how we measure that. I guess scoops of ice cream. Scoops of ice cream sold. So the hotter it gets, the more ice cream sold at lunch. Positive correlation. Let's take this one. The more money you spend, the less you have in your wallet. So